the part 2 of irrational numbers. So I need to consider those cases of irrational numbers again. You know, irrational numbers are numbers that cannot be expressed as fraction. So, and they usually bring the picture of unterminating non-recurring decimal, like I explained in the previous video. So we have two cases of it, two forms. It can be established mathematical constants or radicals. So what are established mathematical constants? Those constants that we have in mass that we already have constant value for them. For example, pi, like I wrote in the previous video, 3.1415926 5, 4, and so on. This is the value of pi, and I've given you the trick to remember it. So another one is exponential, which is Euler constant. Euler constant also has a fixed value. How do we get the value of Euler constant? Just press shift from your calculator, press shift, then press in from your calculator. So you can put 1 to indicate raised to power, then press equal to. That gives you 2.718. So I will just write it on the screen. On the board, 2.718281828, and it continues like that. So this is also unterminating non-recurring decimal. You can see that there is no regular pattern of repetition of digits, unlike recurring decimals. So all of these kind of numbers are irrational numbers. For example, acceleration due to gravity is also one of them. All those, many of those trigonometric trigonometric functions. So their values are always irrational, but some of them are rational. For example, sine 60. If you press sine 60 in your calculator, sine 60 is going to give you root 3 over 2, which is the same thing as 0.86602540038, and so on. So this is also another irrational number. Does it now mean that all trigonometric functions, all trigonometric values are irrational? No. You still need to confirm some with your calculator, because a counter example is sine 30. Sine 30 is equal to 0.5. So, and this is rational, which is the same thing as 1 over 2. So you can't say that all trigonometry, in fact, tan 45 degree equal to 1. So it's also rational. So most cases, if you are not clear, you can use your calculator to confirm. Now, we also have some logarithmic values that are irrational. For example, log 5 to base 10. If you press your calculator for log 5 will give you 0.69897000043, and so on. Does it now mean that all logarithms are irrational? No, because a counter example is log 10 or log 100 or log 1000, log 10,000. All those ones are rational. Log 10 is 1 and it's rational. Log 100 is 2 and it's rational. So you can always use your calculator to confirm. Good. Then we still have more explanation on this, but I don't want this video to be too long. Now, radicals are roots that are irrational. For example, square root of 2, square root of 3, square root of 5. Yes, square root of 5. Also, we can have, in fact, cube root of 10, fourth root of 4, fifth root of 27. All of these will lead to irrational numbers. So, does it mean that all roots are irrational? No. There are some counter examples. For example, square root of 9, which is equal to 3. and 3 is a rational number. These are counter examples. So, but all of these, they will lead to unterminating or non-recurring decimal. So it means they are irrational. All of these ones now, they will lead you to something like this, numbers like this. So, but something like this will lead you to a whole number. So it means this one is rational, but all of these are irrational. So the code is, anytime you press your calculator for a particular number and you get unterminating unrecurring decimal, then the number is irrational. Thank you.